Well, hey there, everybody. It's your boy, Mr. Perry, and here we are, Unit 1, Lesson 6. Gonna dive into casting and range of values with this lesson. Let's go ahead and get started. So we're gonna start with a little bit of an opening challenge here. What I want you to do is I want you to look at these data types down below and see if you can put them in order, starting with which one requires the least amount of memory, and then ending with the one that requires the most computer memory. So you got strings, doubles, ints, and booleans. Take a second, see if you can put those in order based on what you know and what you think. And then when you're ready, go ahead and continue with the video. I'm going to assume that you went ahead and put these in order. Let's go ahead and see what the answer actually is. So hopefully you figured out the easiest one first, which is Boolean. In order for a computer to store a Boolean value, it literally just needs a single bit. One single transistor to turn on or off can store a Boolean value. So extremely small amount of computer memory for Booleans. Next are ints. Ints actually require 4 bytes. They have dedicated, in Java anyways, Java dedicates 4 bytes of memory space to store ints. Next, you have doubles. Now, doubles require 8 bytes because they have everything on this side of the decimal, and then you also have to store the values on the other side of the decimal. So Java reserves 8 bytes in order to store doubles. And for primitive data types like booleans, ints, and doubles, just notice that they have a fixed amount of memory space. So then there's also, those are primitive data types, like I said. Then there's also strings. Now, strings don't require a fixed amount of memory. They require an entire area of memory, and that's because those are reference data types. One of the reasons why we have the capital letter S on string is because it's a reference data type, not a primitive data type, which we write with all lowercase letters. So there you go, just a quick little review of memory and data types. And this is going to be important because in this lesson we're going to be particularly concerned with ints and doubles. So let's go ahead and jump in with those 2 data types. So we're going to start with some vocab here, and we're going to start with what's called casting. So casting is when you change a data type of a value being stored as a variable or resulting from an expression. So you can see down here, int amount is 150, int count is 40, and then down here we're trying to calculate the double, or we're trying to calculate the average. But of course, to calculate the average, you would take the amount and you would divide it by the count. Which always means this would potentially result in a decimal. But the problem, of course, is that amount was declared as an int, and count was also declared as an int. And we know that if we divide an int by an int, we're going to get an int. So what that means is we need to change one of these values, either amount or count needs to be treated as a double before this calculation is performed. So in Java, what you do is you can create your variable double average and set it equal to. But when you go ahead and instantiate this, in parentheses, put the word double next to the word amount. And what that would do is, again, according to our order of operations, we need to get rid of this parentheses first before we do our division. So amount gets casted to a double. So amount would now be 150.0, and then it would do the division. And of course, a double divided by an integer is going to give you a double. So that means when it calculates the average, we're not going to lose any of that value. So that's one way that you can perform casting. So there you go. This is what we mean by casting. You could also do amount divided by, and then in parentheses, double count, which means, again, that this would convert your count variable to a double first before performing that division. So that's another way that you could do it. But as long as either the numerator or the denominator is cast to a double before you do the division, then you're going to go ahead and get the correct value that you are looking for. So here's what that would look like on the other end. You could do amount divided by double and then count this way. That would also properly cast your integer to a double and then give you the correct value. So casting is usually needed in order to avoid the problem of truncating or dividing, in order to avoid the problem of truncating with dividing an int by another int. Remember, doubles require more memory space than integers. And when you divide an int by an int, the result is an integer, which doesn't have enough space in memory to store the extra value for the double. So, all of that decimal value just gets truncated, just gets left off. And this is a common problem with Java. This is a common issue that you will see on your AP exam. And again, the solution is to go ahead and cast. So there you go. There are two types of conversions that you can do. There's a widening as well as a narrowing conversion. A widening conversion is when you cast an int to a double. Ints require a narrow amount of memory, a small amount of memory. Casting an int to a double widens the amount of memory used to store that value. So in general, when you do casting, you're typically doing a widening conversion because typically you're trying to use casting as a way to make sure that you're not losing any value. Like I said, there's also what's called a narrowing conversion. You can cast a double to an int just by putting in parentheses int next to a double value. That would be a narrowing conversion where you're taking a double, which is a larger value, and casting it to an int, which is a narrower. But typically on your exam and typically in this class, you're going to see widening conversions. Okay, and then another thing we're going to get into with this lesson is how do we round to the nearest positive integer? If you have a decimal value and you want to round up or you want to round down, there are a couple of formulas that you're going to want to remember. And when I say remember, I mean commit them to memory. This is something that you might have to do on an FRQ, and you would just need to know, you would just need to remember this equation down here. So let's look at how do we round to the nearest positive int. So we've got double num equals, and then we're casting 12 to a double and then doing our division here. So this is obviously going to be 1 point something, right? It's going to be some decimal. Let's see what it actually is. It's going to be 1.7. Now what we want to do is we want to round this, and so obviously this should round up to 2, right? And so the formula for doing that is to take our variable num and then add 0.5 and then cast this double to an int. We're actually going to go ahead and perform that narrowing conversion. So what ends up happening is right now num is at 1.7. So when we get to this next line of code, we're declaring an integer, calling it round num and setting it equal to. And so we're going to do 1.7 plus 0.5, which takes us up to 2.2. But then, of course, when we cast that to an int, it just laps off that decimal, so we are left with 2. So this little formula that you see right here, casting it to an int, and then you add 0.5 to the value, that's going to round to the nearest positive integer. So again, this is something that you want to remember. Let's go ahead and try another one. What if we want to round down? So let's go ahead and do that same thing, but this time 12 divided by 5, which is 2.4. So this should round down to 2. So again, if we add 0.5 to this value, that takes us up to 2.9. And then, of course, when we cast 2.9 to an int, we lap off that 0.9. We are left with number 2. So that's how you round to the nearest positive integer. All right, again, remembering this little equation that you see here. Now the same thing works, or a similar equation works when we want to round to the nearest negative integer. If we're dealing with negative numbers, we need to use a slightly modified equation. And so now we're looking at double num equals, and we're doing negative 12 divided by 7, and we're casting the negative 12 to the double first. So this will go ahead and give us our proper value of negative 1.7. Now here is our round negative number, and it's almost the exact same thing except we're going to subtract 0.5. So let's go ahead and look at how this plays out. Negative 1.7 rounded to the nearest negative integer, we're expecting it to be negative 2. Now when we subtract 0.5, we take it to negative 2.2. And then again, when we cast this double to an int using a narrowing conversion, the 0.2 is lopped off, that gets truncated, and we are left with negative 0.2. So we get the proper value that we were hoping for. Let's go ahead and try one more. Negative 12 divided by 5. And again, as long as we're casting our negative 12 to a double, this is going to give us a double value. So that ends up with negative 2.4. Now again, when I round this to the nearest negative integer, I'm expecting it to be negative 2. So let's try it with our equation down here. Num minus 0.5 takes us to negative 2.9. And again, when we cast this to an int, we lose the negative 9. Once again, we are at negative 2. So our equations, int, or taking num plus 0.5 and then casting that to an int will round for any positive decimal values. And then taking num and then subtracting a 0.5 and then casting that to an int will round for any negative decimal values. Okay, so there is that. The last concept that you're going to explore in this lesson is a special value that we have. And this will, again, the syntax here will look a little bit strange, but we're going to learn later on in the class, we're going to learn about the wrapper class. And that's when we can start referring to integers with a capital I and spelling it all the way out instead of just calling it ints. So in this thing called the wrapper class, we have an integer. And if you just type out in Java, if you just type out integer.min underscore value, or if you type out integer.max underscore value using all caps, here and here, it turns out that this is a direct reference to a couple of special numbers. So remember that ints are stored with a 4-byte limit. So what that means is the highest you can count is this number right here. And that also means that the lowest you can count is the negative value of that same value. So integer.max value is always going to return this number that you see right here. And then integer.min value is always going to return this number, or reference this number that you see down here. Now let's see what happens if we try to go outside of that value. And again, this is a concept that you're going to need to be aware of for your AP exam. So here we have a variable, int num equals, and I'm setting it equal to integer.max value. So we're at that really, really big number. But now notice what I'm doing, num plus plus. So I'm going to try to add 1 to this value to exceed this maximum limit. And then I'm going to print out the value of num. So go ahead and take a second and make a prediction. What do you think is going to happen? How do you think Java is going to behave if we try to do this? I'll give you a second to pause the video and make your prediction. And now we'll go ahead and see what happens. So what ends up happening is something interesting. What Java wants to do is it wants to send a cue to the programmer, hey, something's gone really, really wrong. And what ends up happening is whenever you try to exceed that value, it bumps you all the way over here to the negative extreme. So you end up printing this, weird, long negative value. And that's because you just got bumped all the way over to here at this end of the range of what an int can store. So this would be an indication. If you're at this really, really large number and you tried to go higher than that, and suddenly you're seeing negative values, then this is a pretty good indication that you probably exceeded the max value for counting in integers. And similarly, if you try to do the opposite of this, if you say int num equals integer.min value, then that means num is going to be right here at the negative extreme of this. And if you try to subtract 1 from it and then print it, as I'm sure you've probably guessed, it's going to bump you way over here, and it's going to place you at the max value. So again, if you're dealing with negative numbers and you suddenly you see that you're getting positive numbers for your result, once again, that would be an indication something's gone wrong. So this is how you get sort of an error message from Java, or this is how Java tries to cue you that something's gone wrong. All right, so a quick lesson review, and then we'll be done here, guys. Casting, or what is sometimes called typecasting, is a way to change an int to a double or a double to an int in order to avoid errors in calculation when dealing with division or fractions. Int num plus 0.5 can be used to round to the nearest positive whole number. Int num minus 0.5 can be used to round to the nearest negative whole number. And then integer max value and integer min value are special ways a programmer can utilize the upper and lower limits of ints. But just remember that if you try to exceed them, you're going to get those weird errors. All right, guys, with that, we've come to the end of the video. As always, leave a question or a comment, and I will see you in class.